Hey, hello everybody. This is actually a session from codingo.com. This is exclusively for Java 8 streams frequently asked coding interview questions. Okay, I'll quickly go over the agenda of this particular session. The core agenda is to take you over the frequently asked coding interview questions related to Java 8 streams. There are 5 to 7 questions that actually covers the end-to-end of Java Streams API, and that's all. At most you would need to know to get into a basic and an advanced level understanding of streams. Um, okay, so before I'll actually show you the main core of this particular session. We'll cover all these coding questions by writing the code. We have a stub in place which actually tells you like what is the prerequisite, and then we'll actually code together. Okay, and these are the coding frequently asked interview questions. You can take a note of it as in the session, and I really don't want to jump directly over this. Okay, and we will actually take a little bit backstep, cover the a little bit around the basis of it. Okay, so what would be the basis of streams API? So where does the streams API comes in, right? So streams is used to basically, you can, do a lot of things like, filter out some data in the collections. You can do some comparisons. You basically can apply a lot of, operations on your collection of data. Okay. So now, uh, what else do you need to know before actually getting into streams? Of course, lambda expressions and functional interface. Why how does these three actually pair up, right? We'll definitely come to know. Okay, now so streams are commonly used along with the lambda expressions, or we can say lambda expressions are used along with the streams, and lambda expressions are nothing else but you are implementing an abstract method of a functional interface. That's where we use a lambda expression for. So then we reach the functional interface. So let's start with the functional interface. We'll get into functional interface, lambda expression streams, theoretical concepts, a little bit on the programming very quickly, and then we'll dive directly into the coding interview questions. Okay. Now, so what is functional interface? So functional interface is like just like an interface in Java, a Java 8. Now, what is it? Why do I say like Java 8? Now, as all of us by this time know that the difference between interfaces in Java 8 versus prior to Java 8, right? So prior to Java 8, we only have an abstract methods in interfaces, but from Java 8, we have the interfaces can have default methods, n number of default methods, which means the concrete methods where you have actually implemented some logic, right? It's not an abstract method, it is a concrete method. So you can have n number of default methods. You mark that with a default keyword like this. Okay, you mark it with the default keyword. You can have n number of default methods in an interface. You can have n number of static methods on an interface. That's what Java 8 interfaces. Now Java 8 functional interface, what's the difference in Java 8 normal interface versus Java 8 functional interface, right? So functional interface is just like other interface in Java 8, but the only thing is that it can have only one abstract method. In a normal interface in Java 8, you can have n number of abstract methods. Like you can define like my method 1, 2, 3, etc. Like abstract does not have a concrete implementation. Okay, but any interface which in Java 8, right? Any interface which contains only one abstract method, doesn't matter it has one or many or zero default methods, or one or many or zero static methods, doesn't matter. But if an interface is having only one abstract method, and then that interface is called a functional interface. We will directly we I mean If you already have worked on lambda expressions, you would be knowing how you can actually use lambda expressions for implementing this abstract method. Okay, and there is actually a reason why we are insisting that a function interface should have only one abstract method, because when we use lambda expressions, right, we will come to lambda expressions. I'm not going to detail of it, but we need to know about lambda expressions in order to get into streams API. So lambda expressions, right, like what is it like? So a lambda expression, you actually don't give a name to it, right? It's just like an anonymous method that you write. correct? uh, Now see, the secret or the magic, like how, like when you actually implement a function, sorry, lambda expression, you will just say, just put like parentheses and define few things. You don't define any name to it. So how do you identify that we are implementing this particular method of the functional interface? Unless you give the name of the method, how does Java understand that you are implementing this function interface? This method, it could be something else, right? So that is why we are actually saying that a function interface can have only one abstract method, because you don't need to give the name of it, because as long as it's a function interface, then it has only one name. Then by default it actually refers to this particular method. So that is why you are able to use lambda expressions on a function interface. You cannot use lambda expressions on normal interfaces, because uh, yeah, so you cannot use it on normal interfaces. Because why? Because if you have multiple abstract methods, then you are not giving a name to the lambda expressions. And how does lambda expression know that this represents, I am actually going to implement this particular method? Okay, so that's actually the secret contract between the functional interface and lambda expressions. Like lambda expression can only implement a functional interface, right? A single abstract method and of an interface. Okay, now so that's a quick tour of the functional interface. Now we'll get into lambda expressions. So of course we all know by this time, like, what is lambda expression? A lambda expression used to implement the abstract method of the functional interface. A body of a lambda expression, thus the body of the function represents, is specified to the right in the lambda declaration. This is the basis of this. If you look at this, this is how. So this is a service method. Okay, sorry, this is a service interface. A service interface has got a single execute method. Fine. So how do we actually implement this particular interface? We'll write a class which implements this particular interface, and we'll override the execute method and give a life to it. Okay, so like we are actually implementing this particular method, abstract method of this particular interface. This is a normal way. Is there a sorry for that. Is there a different way of doing it? Yes, of course, there is a different way of doing it. That is how we do in threads runnable and all. We actually You can actually do this like this, right? You have a service. This is a service interface. You say new service. This is actually interface, and you're saying new to it. Okay. What you mean is actually this part. Okay. This is an anonymous class. So this here we actually created a class which implements a service. This particular class has a name called service IMPL, but here this is anonymous. This class does not have a name. We are saying we are implementing an anonymous class, okay, for this particular interface, which will actually implement this particular method. Okay, now lambda expressions make our life so easy by telling us there is no need to do like this. You don't need to create a class just for implementing one method, or just to implement this particular method of the interface. You don't have to create a class that implements an interface and then and override the method and then do this thing. Neither do you have to write an anonymous class to do this. So what else can you do? You can Java 8. Wow, this interface is having only one abstract method, correct? Which means this is a function interface. You don't need to annotate with the add function interface. Fine. I mean, annotation is actually telling you a data about data, right? I mean, giving you some information that's reader friendly and everything is good. And if you put this annotation and you write multiple abstract classes, it's going to complain. So it will help you, but it's not mandatory that you should mark it. Okay, so this looks like an abstract the functional interface now. So which means you can use a lambda expression. As we said, it has got only one method. Okay, so that's why we are using lambda expression for it. Now how do you implement it? You say service equals. Now you're directly putting the lambda expression over here. Lambda expression, we know, like, it is this thing. Now this one arrow, and then you have writing the content of it. Okay, so whatever you have written over here executing the engine, that's what you write it over here. Okay, now this thing, I hope you guys are familiar with lambda expressions. Otherwise we'll go through another session for function interfaces and lambda expressions. But just to quickly go through it, like, what does this mean? This is actually representing the method that you are implementing. Does it have any argument? No. The execute method does not take any argument, so that is why you are saying just as is like this. And what is the implementation? Like arrow and then braces starts, that actually represents what are you going to implement inside this, right? There's, what we are doing is just one line saying executing the engine. Okay, so we are able to use a lambda expression in order to implement the abstract method of a functional interface. Okay, now I'll actually take you to this thing. So I already kept this for you. This will be available at the end of the session. So this one you can see like okay, this is our service interface, a service IMPL, correct? And this is not needed, okay, if you are directly implementing like this. Okay, I mean if I take this guys out, then you can, when you say like I'm going to create new service, see, it actually auto completes, like, you know, it's going to override the execute service, and now we can put the logic over here. Okay, now how can we do this? Is same as, you know, you might be familiar with this thread and runnable class. If you say runnable equals, you know, new runnable, see, this is the anonymous class which implements the runnable interface, where you can override the run method and write your logic inside this. Now instead of this, if you're using lambda expressions, you will just put like, you know, this is my method signature which does not take any parameters. Okay, now what is the implementation to it? The implementation, whatever that you're going to write over here. Okay, so that will go here. That's it. Instead of writing an anonymous class, instead of writing a class that implements the interface and overriding it, lambda expression makes your life so easy. Okay, this is how we actually do that. Now um, we've already taken 10 minutes for the session, fine, but this is very much needed, function interface lambda expressions. Now we go to streams API. So what is streams, right? Stream API is used to process a collection of objects, right? So long time back, I have read, like, you know, when I'm actually getting into getting familiarized with the Streams API, you know, I was reading an article where it clearly says, you know, a car manufacturing unit where you have a, you know, stream of car, and you know you want to apply a paint to that paint to a collection of cars. What do you do? It's actually a stream of car, you know, in a chain, in a belt, it's coming, and you know you take each car and apply. There is another apply method, or you can say apply utility, which actually applies that paint to that car one at a time. If you have a collection of 10 objects, you take the first object, do it, and take the second object, do it, third object, do it. So that's how it goes, right? So stream API is used to process a collection of objects. If you have a collection of objects where you want to do some processing, you actually can convert that particular collection to a streams and then do the processing. Okay, now, does a stream store data? No, it is not a data structure. Stream is not a data structure, so it cannot store your data. The only thing it does is it takes an input from your collections. Okay, it will not modify the underlying data structure. So if you let's say you have a list of employees, you're converting that into a stream of employees, your underlying data structure, which is the list, is not gonna change. Okay, the only thing is that it will take your data, do some processing, and then provide the result as per the pipeline methods. The pipeline method is like streams is, sorry, my mouse is going a bit crazy. Okay, so the underlying methods is actually the terminal operations and intermediate operations in streams. Okay, so like this is a stream, like employees is like, let's say employees is actually list of employees. Okay, then you will say employees dot stream dot filter dot collect. Okay, so this is like you're filtering it and then you're collecting it, and this is actually not a basis of streams API. We are actually going over the coding interview questions, so with a basic assumption that you guys are aware of how to use streams, okay, and you have used the streams API before. Okay, okay, perfect. So so you have this employees, the list of employee objects. How do we convert that to a stream? We call dot stream. Java supports this dot stream from Java 8. So if your employees, this is actually a collection. If this is an array list, assuming it's a list, right, then the moment you put a dot, then it gives you that option of, you know, calling a stream, taking a stream out of this. Okay, dot, then you can see like dot filter, dot collect, and all these things, right? So filter is what we call as an intermediate operation, because intermediate, as the word says, that is not going to give you any result. If you just say filter and then put a semicolon, that is not an end, which means absolutely it's not going to do anything. That's why we call intermediate operations a lazy operation, because it actually doesn't do anything unless you call a terminary operation like collect, right, or for each, something like that. That is when actually your intermediate operation is executed, and the data is actually collected. So intermediate operations, what is the input of an intermediate operations? It's a stream of data. What is an output? Again, a stream of data. Okay, it will not mark it as completed. Terminal operations are the one which are terminal, meaning they produces streams. Okay, so stream producing operations, sorry, intermediate operations, stream producing operations, and terminal operations mark the stream as consumed. Okay, so once you invoke the terminal operation, then your stream is closed. Now you cannot put a dot and do something else. Okay, now what is the connection between lambda and strings? Why are we talking about lambda? Why have we talked about lambda? Of course, we know lambda expressions are used, most commonly used along with streams, right? Like this particular thing, right? We saw stream dot filter. Uh, okay, you might have seen the zero get salary greater than this thing and all, right? So whatever that you write inside this is actually a lambda expression. Why have you used a lambda expression? That is because this filter takes an argument which is of type functional interface. So you are going to implement the functional interface, and that is why you have written a lambda expression to in order to implement that particular logic. Okay, now let's go further. So when I say lambda expression, right, so see, this is actually from docs.oracle.com. You can actually see uh, all the documentation. So I just expanded one of it, like filter, which is the most popular. Filter is very much frequently used in strings. Okay, so stream, when we call like stream dot filter, what is the argument to the filter? It is predicate. It says predicate. And what is predicate? Predicate is a functional interface in Java 8. Okay, this is a signature of this. This actually takes an argument t and returns what? So this interface, it says t, and t is used when you look at this. This is the interface signature, and this is the method, right? So method says that it has got a test method, okay, which takes an argument of type t, where you have defined over here. Okay, so this is a functional interface which contains a method, an abstract method, which takes some argument of type t and always return a boolean. Okay, so now going back to what we mentioned over here, dot filter. Why did you use a lambda expression here? Because dot filter is expecting a predicate functional interface implementation. Okay, so this is expecting a predicate functional interface implementation. And how can you implement a predicate functional interface in Java 8? How can you implement a functional interface? By using a lambda expression. And predicate actually takes an argument. Okay, what is your argument here? The argument is whatever is coming out of this employees.stream. We are assuming that this is a list of employee objects, so we are saying it is each employee dot get salary greater than 10,000. Now this is an if condition, right? If salary is greater than 10,000, and if condition always returns a boolean. Okay, so this is exactly matching the implementation that we are expecting, right? We are looking for a predicate interface implementation. That is why you implemented lambda expression that returns a boolean. Okay, so that's where, like, so now we are actually talking about the relationship between streams, the lambda expressions, and the functional interface, which is actually expected, right? An implementation of functional interface, what is expected within the filter. Okay, so that's how we connect them. Okay, now with that, we'll directly go to the coding interview questions. That's what the primary agenda of this session. Now, okay, we are 20 minutes past. Okay, so Let's see one by one. So I have actually curated this particular article in a way that, if you want to pause this particular session just to see what is, specific this one, you can actually cover it over here. Actually, I've high color coded everything to relate, like, what each one is. Okay. Uh, okay. So let's go by one. Um, so the first one says print employees whose salary is greater than an amount. Okay. Um, so I have actually given a stub here. The first one says print. So what we need is we have a list of employees, employee list, a list of employees. Okay, employee list dot add. We have added 4 employees with a name. What all? I don't know. Wait a check. What is employee definition? It says name, department, salary, and it's whether it is an active or inactive. Okay, fine. So there's a name, department, and the salary. Correct. If you mouse over it, you will be able to see name, department, salary. So what are we going to do here? We are going to find employees whose salary is greater than, let's say, 5,000 or 4,000. That's what we can put, 4,000, right? We will get okay. Okay, so we are going to print the list of employees who is greater than, if salary is greater than a particular amount. Who can we start with? So we have a list of employees. Okay, so employee list. Okay, employee list uh, dot. Okay, now I want to create a stream out of it. Okay, now you will get the stream from this. Now what do you want to do? You want to basically filter from the set of employees based on the salary. So of course you write a filter. See, it's saying filter needs, it's expecting a predicate interface as an argument. Now how can you implement this predicate interface? Yes, by using a lambda expression. Okay, now predicate, we saw that, predicate is something which has a method called boolean, test t, right? What does it means? This means this is taking an argument which is of type that string containing, right? So what does string contain? String contains employee list. Employee list is a list of employee objects. So here, this, if you write something like this e, then this e is being interpreted as an employee object. That is why if we say e dot something, you get all the methods of the employee object. Okay, this is lambda expressions. We'll have a section on lambda expressions which will cover all these things. Okay, now what is our thing? Okay, we want to find all these salaries greater than, let's say, 4,000. Okay, so now we have filtered the string dot. Now what do you want to do? No, I just want to print. Okay, I just want to print the employees whose salary is greater than 4,000. Okay, so for printing, you want to print each employee, right? I mean, each employee, which is the output of this. This is a term. So this is an intermediate operation. Okay, and this actually produces a string. Now I want to close it. I'm done with this. Now I want to close it. So I use a ternary operation. You can use a collect, or you can use, sorry, for each and all. But here, if I am going to collect it, then again I have to, take from the collection and print it. So there is another terminal operation in streams where we can actually iterate it over here itself and then print it, right? So I call the for each, and for each, what do I do? I just want to print system.out.println uh, the name of each employees, or the list of all employees, right? So I can use a system dot, right, out. Instead of system dot out, I'll use a method reference so that, it actually uh, oh, you can use a method reference like this instead of writing system.out.println and then, writing it, expanding it. Okay, so what does this means? This means, like, you are filtering the string. What is the filter condition? The salary is greater than 4,000, and then you get for each. So you are expecting now these two employee objects, this employee object and this employee object. Then you are saying system out.println. So what are you printing? You are printing the employee. You are not printing just the names, you're just printing all the employees. Okay, now when I call this, okay, I want to make sure that my employee object has a toString method implementation. Okay, I have overridden this particular method and say telling, like, like this, right? Okay, So that is why when I just go over here, I'll be able to print it. Okay, let's run this. So for some reason, IntelliJ actually takes some time when you're running it for the first time. And actually, it's a good practice to